Hello everyone. In this video, we cover the recursive formulas for life annuities. Consider the whole life annuity deal. We have this stream of payments. The expected value of all these payments is given by this expression. And here we keep the first term, isolate the first term, and then for the remaining terms, factor out the expression u times px. The expression within the parentheses corresponds to the actuarial present value of the whole life annuity due at age x plus 1. And then we get this recursive formula. Get back to the diagram. Divide into two parts. The first payment of 1, everyone will receive this amount of 1 at this time point. And if the individual survive to age x plus 1, the actuarial present value of all the future payments at this time point is a double dot x plus 1. Discount back to hx, and we get the relationship. For the nth case, similar argument. The first payment, the amount is 1 over m, and then the remaining payments. If the individual survive to age x plus 1 over m, the actuarial present value of the future payment is a double dot x plus 1 over m, and discount back to hx, we get the relationship. For annuity immediate, again, we split the payment into two parts, the first payment and the remaining payments. If the individual survive to age x plus 1, the individual receives this $1, and therefore the corresponding actuarial present value of this $1 at age x is 1 times nu px. And the remaining payment, the actuarial present value at age x plus 1 is the whole life annuity immediate at age x plus 1. Discount back, and we get the relationship. Okay, so we have gone through these three expressions. And for the nth case for annuity immediate, similar pattern. For the continuous case, split it into two parts. The payment in the first year, we have a bar x colon angle 1, and we can evaluate this using integration. And then the remaining payments. When the individual reach age x plus 1, the actuarial present value of the future payment is a bar x plus 1. The whole life continuous annuity issue at age x plus 1. Discount back, and we get the relationship. All right, move on to the term annuity. N-year term annuity deal, only for the first N year. Divide into two parts. The first payment, everyone will receive this amount of 1. And then the remaining payment, if the individual survive to age x plus 1, this corresponds to the actuarial present value for an N minus 1 year annuity deal issued to a person at age x plus 1. Discount back, we get the relationship. For the nth case, similar argument. The first payment, 1 over m. And then if the individual survive to age x plus 1 over m, the actuarial present value of all these future payments is given by this. Discount back, we get the recursive formula for the nth case. For annuity immediate, again, split it into two parts, split the payments into two parts. If the individual survives to age X plus 1, at this time point, the payment is 1, discount back to age X. And then the future payments at age X plus 1, this corresponds to the present value of an N-1 year annuity immediate issued to age X plus 1, discount back. And we get this relationship. Similar case for the nth N-year annuity immediate. For the continuous case, similar structure. The payments in the first year, A bar X colon angle 1, and then the remaining payments up to age X plus N. If the individual survives to age X plus 1, the actuarial present value of the future payments corresponds to A bar X plus 1 colon angle N minus 1. Discount back, we get the relationship. For deferred annuity, an N-year deferred annuity due, the first payment is at age X plus N. When the individual survives to age X plus 1, the actuarial present value at this time corresponds to an N-1 year deferred annuity due at age X plus 1. Discount back, we get the relationship. For the nth case, the first payment at age X plus N, the payment amount is 1 over M. When the individual survives to age X plus 1 over M, then the remaining period, the remaining deferred period is N minus 1 over M. So we have an N minus 1 over M year deferred annuity due at age X plus 1 over M. Discount back, and we get the relationship. For annuity immediate, here the annual case, the first payment is at age X plus N plus 1. When the individual survives to age X plus 1, the actuarial present value of the future benefit is N minus 1 bar AX plus 1. And we get this relationship. For the nth case, again, similar structure. For the continuous annuity, the N-year deferred continuous annuity, the payments start at age X plus N. At age X plus 1, if the individual survives to age X plus 1, the corresponding present value, and then discount back, and we get this relationship. The last one, certain and life annuity. Consider the N-year certain and life annuity due. The first N payments of 1 are certain, even the individual dies. Split it into two parts as usual. The first payment of 1, the individual definitely received this amount of 1. And then the remaining payments. If the individual dies within the first year, before reaching age X plus 1, The actuarial present value for the remaining payments corresponds to an n-1 term annuity due. This is certain. A double dot angle n+1, because this payment is still within the certain period. If the individual survive beyond age x+1, then the actuarial present value corresponds to this. Corresponds to an n-1 year certain and life annuity due issued to age x+1. Death occurs during the first year. We multiply by the actuarial present value factor nu, and then times the probability the person dies within this 1 year, which is Qx. And then if death occurs beyond the first year period, multiply by nu Px. Sum this up, we get the recursive formula. The first term is the present value of this one. The second term, A double dot angle n-1, discount back, and multiply by the probability that the individual dies within the first year, Qx. And then the last term. Similar for the nth case. The first payment, 1/m, is certain. And then if the individual dies before reaching age x+1/m, the actuarial present value of the remaining benefit is only the payments within the certain periods. Otherwise, this corresponds to an n-1/m year certain and life annuity due issued at age x+1/m. Discount back. And we get the recursive formula for the nth case. Very similar structure. For certain and life annuity immediate, if the individual survives to age x+1, then the individual will receive this $1. And if the individual dies, the individual also receives this $1 because this is within the certain period. And therefore, the present value or the actuarial present value of this first payment one, we simply multiply this one by nu. It doesn't matter whether the individual dies or not. And if the individual dies within the first year, then the actuarial present value for the remaining payments is the n-1 term annuity immediate. This is certain, annuity certain. And if the individual dies beyond the first year, the corresponding present value, we have the n-1 year certain and life annuity immediate at age x+1. All right, so the actuarial present value for this annuity certain is nu times Qx. The individual dies within the first year. And then the last one here, the actuarial present value is nu times Px. The individual survive beyond the first year. And we get the relationship. Similar case for the FD, annuity certain and life annuity immediate. No matter the individual survive or not to age x+1/m, the policyholder or the individual will still receive this 1/m. at this time point. And then for the remaining payment depends on the survivorship, the survival of the individuals. And we get this relationship. For the continuous case, the payments for the first year, A bar angle 1. And then the payment is certain for the first n years. If death occurs during the first year, then the actual present value of the remaining payment corresponds to the actual present value of an n-1 year certain and life continuous annuity issued to hx plus 1, but this is within a certain period. So this is an annuity certain, A bar angle n plus 1. If the individual dies beyond the first year, so we have n-1 year certain and life continuous annuity at age x plus 1. Discount back. And we get the relationship. All right, so that's it for today's video. We only cover the relationship or the development of the recursive formula. In the next video, we'll go through some examples using the recursive formulas. Thank you for watching and see you in the next video.